how many numbers are there between 1 and 100 that are divisible neither by 2 nor by 3? Now if you ask me, this is a typical Venn diagram question which looks confusing at first sight. But let us jump into it. Draw it like this. This is one rectangle. Let this circle represent, I'll call it A. This represent all the numbers that are divisible by 2. And B is the set of all numbers that are divisible by 3. Now some numbers will be divisible by 2 also and 3 also, so they can be put in this common region. And any number that is outside of these circles, that will be our answer. So if we know how many numbers are there which are divisible either by A or by B, either by 2 or by 3, then we can subtract that count from 100 and the balance will be our answer, because they will be divisible neither by 2 nor by 3. So let us proceed now to find out those numbers which are divisible either by 2 or by 3. Now let's see this one. 1, 2, 3, 4, 5, like this. This is the counting. Every alternate number is divisible by 2. So every second number is divisible by 2. So how many such numbers will be there between 1 and 100? We can find out by writing this 100 by 2 equal to 50. So we can say that number of A is equal to 50. This represents all those numbers that are divisible at least by 2, because some of these would be divisible by 3 also. Okay, now again look at this again. 3, 6, 9 and so on. So every third number is divisible by 3. So how many numbers will be there between 1 and 100? We can say 100 by 3, which is approximately equal to 33, round figure. So we can say there are NB is equal to 33. There are 33 numbers between 1 and 100 that are divisible by 3 at least. So according to our set notation, NA is 50 and NB is 33. Next, let us take out how many numbers are divisible by both 2 and 3. So any number that is divisible by both 2 and 3 will be a number that is divisible by 6. So we can say every sixth number is divisible by 6. So if we want to find such numbers, then we can write 100 by 6, which is approximately equal to 16, round figure. So we can say NA intersection B is equal to 16. If you're clear up to this point, probably you might be having small difficulty with this part. But if you think about it a little, you will be able to understand that this is correct. So if we agree on this, now we can use our Venn formula. NA union B is equal to NA plus NB minus NA intersection B. So this comes out to 50, add 33 and subtract 16. So it will be 83 minus 16, and this figure will be 13 minus 6, 7, 67. So there are 67 such numbers between 1 and 100 which are divisible by 2 or by 3. And the remaining is 100 minus 67. So this will be 33. So there are 33 numbers between 1 and 100 that are divisible neither by 2 nor by 3. So this is how we solve this question. In this you should also appreciate how these basic set formulas, they came to a rescue here. They helped us a lot here. Instead of putting figures here in these diagrams or the way our analytical books they solve the questions, this is a much more systematic and safe way of doing things. Let us now move on to the next example. In a class of 30, there are 10 who take tea, 15 who take coffee. If 3 take both and others take none, how many take exactly one drink? Now this question also is looking very confusing at first sight, but it's not so. Because after all, there are going to be the same Venn diagram, the same areas. One thing is written in one language, other is asked in another language. The question has to be from those things only. So let us see how this one is a typical Venn diagram question that can be easily done. In a class of 30, there are 10 who take tea, 15 take coffee, 3 take both and others take none. So it means this 30 includes those also that take none. Let us begin by drawing a Venn diagram. Okay, this is a container and here I'll write NC and this is for the tea part, NT. So in a class of 30 there are 10 who take tea. Now this 10 means, as I always tell you, try to cast these figures into the language of Venn diagrams, into the language of the sets. There are 10 who take tea. Now he says this take tea, he hasn't used the word only here. So what he means here is that these 10 take at least tea. So we can write NT. This is for at least tea. It is equal to 10. Similarly, 15 who take coffee, so they are also at least ones. NC is equal to 15. 3 take both. So here also we can write T intersection C is equal to 3 and others take none, the remaining take none. Now he says, how many take exactly one drink? Exactly one, now others take none. It means the people who take exactly one drink are those that fall in this part and they fall in this part. Exactly one means these people take coffee only and these take tea only. Now outside this nobody takes anything and inside this people take both. So it means we have to basically find this hatch and this hatch. So let us cast this into the language of set diagrams. Here now, what is this hatch? This hatch is NC underscore. See my earlier lectures for this. And this is NT underscore. So we have to find NC underscore plus NT underscore. Let us now put them into one mathematical equation. We know that NT union C is equal to NT minus NT intersection C plus NC. This is one thing I know. And okay, right way I'll put the values also. This will be 10 minus 3 plus 15 equal to 25 minus 3, 22. So this is one thing I get, the union. And I also know now I have to find these. So it means I have to hook the second equation. The second equation says NT union C is equal to NT underscore plus NT intersection C plus NC underscore. Okay, NT union C I have found here as 22. So whatever is available, write it here. And NT intersection C is available to me from this. So this 3 is available and this sum I have to find out. So I can just put these two figures as S here for simplicity. So we can write S is equal to 22 minus 3, which is equal to 19. So 19 are those who take exactly one drink. This solution would have been impossible without a knowledge of these two equations. So my stress, as I told in those lectures also, that these basic Venn equations, they are a must for anybody preparing for these analytical exams. And the best approach would be that you pick up those NCERT books. NCERT books are the best resource for this. They will teach you these things. They will contain other stuff also that might not be required by you. But go through those chapters sincerely. You will be able to develop an understanding of this. Okay, let me take to the third example now. Let us move towards the third example and try to solve it by using these equations.